Hello and welcome to today's video. Today's video is for Advanced Geometry Chapter 6, Section 5, Trapezoids and Kites. So today's theorems will deal with either trapezoids or kites. So we start out with a definition and it's base angles and it's for a trapezoid. So if I draw a trapezoid and I make the top and the bottom parallel, the two angles that share a base are called base angles. So there are actually two sets of them. The angles down here are base angles, and also the angles up here are base angles. And we have a theorem that says that if we have an isosceles triangle, then those base angles are congruent. So this one is the isosceles trapezoid. Sorry if I said triangle. Isosceles trapezoid base angle theorem. So we have an example here. It gives us one angle of an isosceles trapezoid and wants us to find the other ones. So if this is an isosceles trapezoid and these are my congruent sides, that means this also has to be 102. And because the parallel lines, the same side interior angles are supplementary, I also know this is 78 and this is 78. So we have the measure of angle A equals the measure of angle D equals 78 degrees. And we also know that the measure of angle C is 102 degrees. Now the next problem is a really kind of a cool problem. It's got this ceiling, or part of a ceiling. And so the ceiling at the left shown is made from congruent isosceles trapezoids. So if you take a look at that part that's outlined in the aqua, that's the isosceles trapezoid. And what it does is it creates the illusion of circles. What are the measure of the base angles of these trapezoids? So what we have to know is how many of them do we have. So it says each trapezoid is part of an isosceles triangle whose base angle are the acute base angles of the trapezoid. And the isosceles triangle has a vertex angle that is half as large as one of the 20 angles at the center of the ceiling. So if I take 360 all the way around the ceiling and divide by 20, I get 18. So this whole angle here is 18. So each part up here is half of that. So each part here is 9. Okay. So I know that this is an isosceles triangle at the top. So if I take 180 degrees and subtract off that 9, I get that this is 171 degrees for the other two base angles. And if I divide them by 2, I get 85.5 degrees for each one of these base angles. Now I know that these lines are parallel, and so what I can say is quickly is I could say, well, these are corresponding angles. So if these are 85.5, then these are 85.5. So I know that the base angles of the isosceles trapezoids are also 85.5 degrees. Done. Oh, I think I had something at the bottom there. Okay. We also know for an isosceles trapezoid the diagonals are congruent, so not for any trapezoid, but if it's an isosceles trapezoid. So the isosceles trapezoid diagonal congruent theorem. So this one is saying if I have an isosceles trapezoid and I know that these are congruent and these are my parallel sides, then both of these diagonals are going to be congruent. The next one I had deals with the diagonals of a kite. The diagonals of a kite are perpendicular. So this one is the kite diagonal perpendicular theorem. So any kite that you can draw, the diagonals are not going to be congruent, but they are going to form perpendicular lines. They're going to be right angles up there. So we'll prove this one in class, prove the diagonals are perpendicular. But there's a problem at the bottom. It's just an algebra problem, so I'll do that one. It says find all the angle measures, angles 1, 2, and 3 in this kite. So if this is a kite, that means that these are right angles, so measure of angle 1 is easy. And that means that all the angles add up to be 180, so the angle 32 and 2 are supplementary. So the measure of angle 2 is going to be 58 degrees. And then the other thing I know, I'll put that in, 58 degrees. If you take a look at the two triangles here, this is for kites. If you draw the one diagonal, it would be the diagonal that would be between the two congruent sides. What you're going to get is you're going to get two triangles that are congruent. So you've got side, 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 and you can say that these two triangles are congruent. So basically the blue one and the red one. Well, if those two triangles are congruent by side, 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 the last side reflexive, then the two angles at the top have to be the same. And so I can say that the measure of angle 3 equals 32 degrees. So that what I talked about for this one is not a part of a theorem, but it's something you should know. It doesn't work for the other diagonal, but it does work if you connect the diagonal between the two sides that are congruent. You get two congruent triangles. And so you know that the angles at the top and the angles at the bottom are congruent. And that ends today's video. Thank you for watching. Take care.